All right, so today we're talking about reflections. So basically, a reflection is something that flips a figure over a line of reflection in order to create a mirror image. Each reflected point of the figure should be the same distance from the line of reflection on the opposite side. A transformation it's a transformation where the figure is flipped over. So it would be a rigid transformation, meaning that the shape and size of the object would remain the same. So first of all, let's look at a reflection over the y-axis. So what do we mean by the y-axis? That's the up and down axis. So if we reflect it over the y-axis, this would be the new points. And let's look at the shape. So the shape would look like that. And so what happens when you flip it over the y-axis, you notice that the x values become their opposites because they just shift to the other side of the x or the y-axis. Meanwhile, the y values stay the same. Oops. So we want to write a rule that could represent the reflection over the x-axis algebraically. So what would that look like if we just did one of those the original x and y value when you reflect it across the y-axis changes so that, like we said, the x value becomes its opposite, so minus x, and the y value would stay the same that it started out as. So that would be the algebraic rule for a reflection across the y-axis. So pretty easy, right? Okay, the next one. What about a reflection over the x-axis? So the x-axis is the horizontal axis, and so a reflection across that would just mean every point in the original figure would then reflect across the y-axis or x-axis and then be same distance above it that they are below it or vice versa. So these would be the new points of the reflected image, which if you look closely says that the x values stay the same, and in this case the y values become their opposite value. So you can see that in the original image all the y values had negative numbers, and in the new image they're all positive because they became their opposite. So what would the algebraic rule for that one look like? So x comma y would become x comma negative y. That would be the opposite image. So there we go. That's the two main rules for today. All right, so triangle ABC, we're going to translate that over, or reflect it over the y-axis and label the image. So if we reflect it over the y-axis, keep in mind the y-axis is this axis right here. Okay, so the first point, B prime, or B, is right on the y-axis, so it's going to stay there. So B prime will stay right there. And it'll be 1, 2, 3, 0, 4 is where that's at, all right? Okay, now C is is 3 to the right of the y-axis, so we're going to move it over 3 to the left. 1, 2, 3. So its new location, it'll be right there, so that'll be C prime. Well, what about A? A is to the left of the y-axis, and it's going to be reflected to the 1, 2, 3 to the right of the y-axis. And so that would be A prime right there. So all we have to do is draw those images, and now we can redraw the triangle. Helps if you have a ruler. And then write the coordinates of the point. So this point would be 1, 2, 3, negative 3, 3, negative 3. And this one would be negative 1, 2, 3, negative 2. So C prime would be negative 3, negative 2. And you get the idea, right? Okay. So that's the one we just did. We just rotated over that y-axis. So the next one, find the coordinates of the vertices of each figure after the transformation listed here. And that's across the y-axis. Well, let me just remind you that a minute ago we discussed that the xy value, when you go across the y-axis, the x value becomes its opposite, and the y value stays the same, right? That's what happens when you go across the y-axis. So if we do that, then the x value would become positive 4 here. Y value would stay the same. And that's w prime. So on this one, we'd have 3 comma negative 2. And that would be v prime. And then u prime would be, okay, the opposite of 0 is a 0, so that's going to stay the same. So 0 and negative 4, so they actually have a common point that doesn't switch. So there's what we would look for after that transformation. Okay, how about find the coordinates of the vertices of each figure after a transformation across the x-axis? So in this case, the xy values, when you go across the x-axis, x stays the same, and y becomes its opposite. So that's what we're going to be looking for. So all the x values will stay the same, so negative 5, negative 2, and negative 1. And then all the y values become their opposites. Well, 0 doesn't have an opposite, so we'll just put 0 again. The opposite of 3 would be negative 3, and the opposite of 1 would be negative 1. So that would be the new letters of the translated images for K prime, L prime, and M prime. Okay, good. All right, on this one, write a rule for the reflection. So choose one original point and find its matching prime point. Connect them, write down the coordinates. Okay, so let's just look at P and P prime. So P is at negative 1, negative 1, 2, 3, 4. Negative 1, negative 4. That's the location of P. So now what about P prime? P prime is at negative 1, 1, 2, 3, 4. Negative 1, 1, 2, 3, 4. So at negative 1, 4 is where P prime is at. So if you look, those stayed the same. The y value switched, and that's, so what did they reflect over? They reflected over the x-axis. Okay, so we're just kind of using the two little rules that we've already learned today. Okay, write a rule for the given reflection. So this rule, this one reflected over the y-axis. So you'll remember that for the rule for going across the y-axis, the x values become their opposite. Y values stay the same. Okay. All right, on this one, we're reflecting it across the x-axis. So in that case, when you go across the x-axis, the x value switches to its opposite. Excuse me, the x value stays the same, right? See how the x is staying the same? And the y value becomes its opposite. That's what happens in that case. So there we go. A couple more. Looks like you're switching across the x-axis again. So x comma y becomes x comma negative y. And then here we're switching across, or reflecting across the y-axis. So our original x comma y values will become negative x, comma, y. And that works for all of these kinds of reflections. Okay, so we got a worksheet for you to do that you can print it off the Today button page, or you can pick one up in class. Thank you very much.